Find out the solutions of the equation z raised to power 4 is equals to 2 plus 2 root 3j, giving you answers in the form a plus bj. In this example, we want to solve a complex equation. So how do we solve this complex equation? We change the Cartesian form into polar form first, isn't it? So we have here z raised to power 4 is equals to 2 plus 2 root 3j. So this is in the form x plus y j. So from there our x is 2 and our y is 2 root 3. So having found x and y, you can now find r and theta. So what is r? R is the Pythagoras theorem, square root of x squared plus y squared. That is square root of 2 squared plus 2 root 3 squared. Then you just put is equals to there. Then you move to the next one. Theta is the tan inverse of y over x. Then you put tan inverse of y is 2 root 3 over x is 2. Then you go to the calculator to give you those values direct, isn't it? We are looking for the polar form of xy. So what is the polar form of xy? So polar form, you put the value of x, polar 2, comma, the value of y is 2 root 3. So what is the polar form of 2, comma, 2 root 3? What is the polar form of 2, comma, 2 root 3? R is 4, meaning this r, which is square root of x squared plus y squared. If you work it out, you are going to get 4, isn't it? Then what is theta? 60 degrees. So it means when you look for the tan inverse of root 3 over 2, you are supposed to get 60 degrees. Or if you draw a complex plane like this to see the quadrant where that complex vector is, you simply check. X is 2, meaning it is positive. So you go on the positive side of the real axis, isn't it? And y is positive root 3, meaning y is also positive. So you go to the positive side of the imaginary axis. So it means that theta is in the first quadrant. And you can see 60 degrees is in the first quadrant. So you just use the calculator to get the polar form of xy. You change it directly, isn't it? So having expressed that, now we have our z raised to power 4 is now in the form r angle theta, where r is the modulus, theta is the argument, isn't it? So the theta you found is 60. You can generate more thetas by adding or subtracting 360 degrees, a complete revolution, isn't it? So the first theta is 60 degrees, so we add 360 degrees, a complete revolution, to generate other values of theta, isn't it? So 60 plus 360 for 20 degrees, for 20 plus 360, 780 degrees. Maybe you can subtract 360 to get one negative angle, isn't it? Are we together? So 60 minus 360, we also have negative 300 degrees. So those 4 values of theta are just enough to solve for z. We can get many solutions, but 4 solutions are enough if z is raised to power 4, isn't it? So even before we substitute this angle, if it is in the form r called angle theta, then you just multiply both sides by 1 over 4 to get rid of the power of z, so that we work with simple things on the spot, isn't it? Are we together? So here it means z will be 4 goes with times a quarter is 1, remain with z, isn't it? So z is what? R raised to power 1 over 4, then angle and theta, meaning a quarter theta, according to DeMoirve's theorem, isn't it? Are we together? Now from there you now start by getting z1. So can you get r raised to power quarter on the spot? So r raised to power quarter, r was 4. What is 4 raised to power quarter? So that you get r raised to power quarter, 4 raised to power quarter. 1.414. So you found r raised to power quarter, isn't it? So the first value of z is z1, where there is r raised to power quarter, you put 1.41, then angle a quarter theta. So take the first value of theta. Let us start with the negative 1, isn't it? Negative 300. So a quarter of negative 300 is negative 75 degrees. You are done with the first solution. You move to the second solution. Z2 r raised to power quarter we found is 1.414 angle a quarter theta. So that's the next value of theta 60 degrees. A quarter of 60 degrees, 15 degrees. Let's go to the next solution of Z, Z3. R raised to power quarter is 1.414. Then take the next value of theta 420 degrees. A quarter of 420 degrees, 105 degrees. Then go to the next value of Z, Z4. R raised to power quarter is 1.414. Then take the next value of theta 780 degrees. A quarter of 780 degrees, 195 degrees. So we found all the solutions in polar form, but they wanted the solution in the form a plus bj, meaning in Cartesian form, in form of x plus yj, isn't it? So in Cartesian form, to change the polar form in Cartesian form, you use the rectangular form of r theta, rect into r theta, isn't it? So let us start with the first one. The rectangular form of r is 1.414, comma, theta is negative 75 degrees. What do you get? To be the rectangular form of 1.414, comma, negative 75 degrees. You get x to be? X is 0.366. Then y? Negative 1.366 j. So x is 0.366 minus 1.366 j. So it is the form x plus y j. Move to the next one. Rectangular form of 1.414, comma, 15 degrees. You get?
X equals 1.
X is
1.36.
1.366. So x is 1.366 and y?
0.366.
That is positive 0.366 j. So it is in the form a plus bj or x plus yj, isn't it? So let us move to the third one. The rectangular form of 1.414, comma, 105 degrees. We have
Negative 0.366.
x is negative 0.366 and y is
1.36.
y is positive 1.366 j. So that is the form x plus yj or a plus bj. Let us move to the last one. That is rectangular form of 1.414, comma, 195 degrees. You found
Negative 1.36.
x is negative 1.366 and y is negative 0.366 j. So that is in the form x plus yj. So that is how to convert polar forms into rectangular form. So if you are solving any complex equation, it can only be solved in polar form, because polar form is where DeMoirve's theorem applies, isn't it? Are you seeing that? And we are done there. Next example.